Bismillah ar-Rahman ar-Rahim. Good morning. Today we have theories of vectors field. The first one of these theories is Gauss's Ostogradowski theorem. The problems of this theorem is to obtain and to calculate the flux for some of charges inside a box. We know that the flux we started from this side and this side of the box. The flux of the side A, B, C, D. It is the vector field cross the area of this side, which is minus AX of X, and the area it is dy by dz, dy by dz, and the flux of the opposite side of the box, which is A prime, B prime, C prime, D prime, it's equal this point x plus dx. So, and we are in the directions plus of x-axis, plus a sub x of x plus dx, and again it is dy dz, dy and dz. It is a prime, b prime, c prime, and d prime. By adding the two flux of these two sides of the box, we get A of x sub x of ax plus dx minus ax of x, all of them times by the area dy by dz. This is equal by Taylor the limit when delta x approximate to 0 for ax of x plus dx minus a sub x of x over dx, dx, dy, and dz. And this is equal the partial ax over partial x dx dy dz. This is equal to volume dv. By this results, I can calculate all the sides of this box. So the j for all sides equal to the partial of a sub x partial x plus partial ay over partial y plus partial az over partial z, all of them times by dv, dx, dy, and dz. I can express of this bracket equal to the divergence, the vector fields of A. And this is dV. But the flux equal to the integrations, surface integrations, the vector field dot ds, the area. So I can write now the integration, surface integrations of A dot ds equal to the in volume integrations divergence A times dV, which is called the Gauss-Ostrovsky theorem. Now, if delta V goes to 0, in other words, the limit when delta V go to 0 for the surface integrations A dot ds equal to the divergence of A dV, delta V. So the divergence of A equal to the limit when delta V goes to 0 for the surface integrations A dot ds by dV, which is the definitions of divergence as we are getting in the last lecture. This is called the source density.